This example comes out of section 1.2, the limit of a function. First piece of this example, we're asked to find the limit as x approaches 4 of x squared plus 3x plus 12. We could try to get real fancy with this and try to put in numbers really close to 4, 3.9, 3.999, 4.01, 4.0001. But the fact is that this function, if I were to think of it as a graph, is continuous and defined everywhere. So it's perfectly fine in a case like this just to put in 4 here and say, well, what does 4 squared plus 3 times 4 plus 12 equal? And so you have 16 plus 12 plus 12, which equals an answer of 40. And so if you were to look at this graph and say, oh, what does this graph look like, and have some very rough sketch of it, you would find that as x approaches 4, your graph is getting very, very close to the point that actually is on the graph, which is 4, 40. So the simplest type of limit that you can see is where the function is actually defined at the value you're asked to find the limit for. So in this case, as x approaches 4, x can equal 4, and you can find the point on that graph. So the answer to this one is 40. Second example looks much more complicated. We're asked to find the limit as x approaches 5 of this rational function x to the 4th plus 5x squared plus 1 over x minus 2. I've seen students, when faced with something like this, just start factoring things or attempting to factor things and doing a bunch of complicated work here. But the fact is that this function, whatever it might look like, is only undefined when x is 2. So I really would only have to get fancy if I was asking something about the limit as x approaches 2. Otherwise, it's defined for any other value of x, meaning that I can actually just find what does 5 give me in this function. So if I have 5 to the 4 plus 5 times 5 squared plus 1 divided by 5 minus 2. So again, if your function or your expression that you're finding the limit of is defined at that value, the simplest way to do it is to just put in the numbers and see what you get. So here you have 5 to the 4 is 625 plus 5 times 5 times 5 is 125 plus 1 divided by 3. So you've got 751 divided by 3. And you could put it into a decimal or leave it as a fraction, but that's about as good as it's going to get. And you don't need to start factoring something unnecessarily here. So a more interesting question then is this one. Part C, limit as x approaches 6 of x squared minus 36 over x minus 6. In this case, I can't just put in x equals 6. If I do, I get 0 divided by 0, kind of that common calculus problem. 0 divided by 0 on any calculator that I've ever seen doesn't give you an answer. In this case, the way to go about this is to say, well, that would be the limit as x approaches 6 of x minus 6 times x plus 6 over x minus 6. In other words, factor everything that I can. In this case, the top factor is as a difference of squares. So I've got the limit as x approaches 6 of x plus 6. The factor, again, common factor top and bottom cancels. And now that I have done that, I can actually just put 6 in here and realize that 6 plus 6 equals 12, and that the answer to this limit is 12. That whatever this graph looks like, as x approaches 6, the graph is approaching a value of 12. This next example looks really different because it's got an h, and I actually even, as I wrote it, made the mistake of putting an x there, because I'm used to having x's in all the previous examples, but really we're just looking at the same idea. What would happen as h approaches 0 in this expression here? Now I can't just throw in a 0 because I do end up with 0 divided by 0, the calculus problem. But if I keep going with this, limit as h approaches 0, the top I can at least expand it out and say, well, this would be 9 plus 6h plus h squared. I still have minus 9 over h, which puts me to have the limit as h approaches 0 of 6h plus h squared over h. That's convenient that those 9's cancel out, because it actually allows me to factor out an h and say, okay, I've got 6 plus h divided by h. These h's cancel. And now h can be 0, and the answer to this 6 plus 0 is just 6. And so the answer, as you evaluate that limit, is that h is equal to 6. You'll run into, in the next chapter, especially in the beginning, a lot of limits that have this limit as h goes to 0 kind of format.